Welcome to the lecture on weldability of metals. So, first of all we must know what is weldability. Weldability, as you know, this is composing of two words, that is welding and ability. So, the ability of the metal to be welded. So, how easily the metal can be welded, that is basically in a very rough way we can say that if you are able to weld the material in easy way, it's more weldable than those materials which can be welded with a lot of difficulty. So, that is in rough sense we talk about the weldability. So, we will talk about these weldability aspects of different materials, and this is important because welding is one of the very important process, very key process in manufacturing, because it is extensively used in most of the structures which you are seeing, larger structures especially. They are there you have lot of use of welding. So, now the thing is that when you do the welding, you always feel that the quality of the joint should be better, there should be proper properties, the properties should not be decreased because of any other factors or so. So, for that you have to be controlling a lot of things. You have to have proper selection of material, proper selection of electrode, proper selection of operating parameters, proper design, proper joint design, fitting and all that. So, when we talk about weldability, so it is the capacity of a material to be welded under fabrication conditions imposed into a specific suitably designed structure and to perform satisfactorily in the intended service. The thing is that you are welding the material or joining, sometimes you have different conditions. You may have the joining with one way, like you may use the flame welding, or you may use the arc welding, or you may use the non-conventional welding processes. So, you may have specific fabrication conditions. Now, and also you have a particular structure which is to be welded. So, when you are doing the welding, you feel that after welding the structure should perform satisfactorily for the intended service. So, it means that once the welding is proper, the properties will be as per desire, whatever you expect the material to behave, whatever the way you expect the material to behave, it will behave in that fashion. So, that's when you can say that the material is proper weldable. Now, weldability basically encompasses 3 points. So, first point is the metallurgical compatibility. So, that is metallurgical compatibility of a metal or alloy with any specific welding process. Now, when we talk about the metallurgical compatibility, it means that the base metal and the weld metal, they can be combined with the proper degree of dilution. So, within certain degree of dilution, they can be combined, and that will not adversely affect the property of the welded structure. So, that is what because what happens that when you talk about the weld metal, in the weld metal zone, if you are using the filler metal, if you are using electrodes, they do not have basically the same composition as that of the parent metal. So, you have some degree of dilution. Now, that dilution which or you have different alloying elements also we put in into the weld metal zone. So, that basically gives you the dilution. Now, what degree of dilution, up to what degree of dilution can be absorbed? So, that is known as metallurgical compatibility, because many a times if it is not metallurgically compatible, it means it may lead to some different sets of phases which may give you undesirable structures or undesirable properties, like you may have the formation of different type of carbides, or you may have undesirable very hard phases or so. So, that will basically be affecting the property of the material or the welded joint. So, that is why we talk about the metallurgical compatibility, and this is very important point, because if they are not metallurgically compatible, if you are taking the plate material as well as in the material in that weld pool. So, that way if they are not having good compatibility, then you may have the deposition of carbides along the grain boundaries that may induce the brittle behavior of the material, or you may have different phases which may be undesirable, which may decrease the ductility or ductile brittle transition temperatures. So, this way there may be effect on those points. So, metallurgical compatibility is that way very important when we talk about the weldability. The second point is the mechanical soundness. So, mechanical soundness means the material which you are welding, and in that weld pool when you have the solidified weld, then it should be mechanically sound, because ultimately the mechanical properties will depend upon the absence of impurities or absence of the blowholes or cracks or defects. So, the a weld must be mechanically sound. Then only you can say, so in most of the cases when if it will be mechanically sound, then at least you can ensure that there will not be premature failure of that joint, because it is mechanically sound. Otherwise, if you have the formation of voids, if you do not control the porosities in the weld zone, or if you are not able to see that you have different kinds of weld profile, or you have cuts or cracks or so, in that case it will not be a sound weld, and then it will reflect on the mechanical properties of the welded joint. Third part is the serviceability of the welded joint. So, it will be talking about the different service conditions under which the weld metal has to work. When we do the welding, because this failure of the component or breaking of the component may occur at any place. So, when we do the welding, we feel that after welding the materials should work satisfactorily, or they can give you the service satisfactorily under any condition, like there may be condition of the impact, there may be condition of low temperature. So, the material must be performing satisfactorily under the different conditions of service, like low or high temperature, impact loads and all. So, in a nutshell, when we talk about the weldability of a material, then if the material has adequate weldability, we must be in a position to tell with confidence that the material's strength and toughness should be quite high after welding. So, because what happens, these are the challenges in welding. When you do the welding and if the heat extraction rate will be too fast, in that case hardness may increase but toughness may go down. So, what you require, what you aim after welding is that you must have the proper strength and toughness even after the welding. Similarly, even with the high dilution, you are able to give the good quality of weld. So, that is another requirement which is there for material to be good weldable. Then you have there is no change in the corrosion resistance of the material after welding. So, because maybe because of the formation of different phases and because of the formation of undesirable phases at the gain boundaries or so, depositions or so, the corrosion resistance may come down. So, that property is also intact, there is no change in that property. Similarly, when you are stress relieving, that time also there is no there is no brittle type of phases which are formed. So, phase embrittlement should not be there. So, these are the points which are basically important when we talk about the proper weldability of the material. Now, when we talk about the weldability, then in the weld pool you have different alloying elements, and how these alloying elements are going to affect the weldability of the material. So, for that we will discuss. So, first is that increase or decrease the hardenability. So, as we know that the alloying elements have a great effect on the hardenability of the material. Now, hardenability is nothing but by the use of these materials. When the material is more hardenable, it means that the material will be more hard even under the normal conditions. So, you suppose for ferrous materials it will try to form the martensitic phase even at the normal cooling rate. So, with certain type of alloying elements they may increase the hardenability. So, hardenability of the HAZ is very important, and some of the alloying elements increase the hardenability and some of the alloying elements decrease the hardenability. Now, if the hardenability is increased, there will be more chances of formation of the very undesirable phases in the HAZ, and in that case there may be improper behavior or improper properties which will be set up in the material. So, the elements which are basically said to have a large effect on the hardenability in case of steel, they are carbon, manganese, molybdenum, vanadium, chromium, all these nickel or silicon, they have a large amount of effect on the hardenability, and some of them have the positive effects on the hardenability and some of them have the negative effect on the hardenability. And hardenability is basically quantized, or it is basically represented in terms of the carbon equivalent value many times, and this carbon equivalent value can be expressed as the percentage of carbon plus certain fractions of these alloying elements percentages, like you may have certain type of expressions like percentage of carbon plus percentage of manganese by 4, or plus percentage of nickel by 20 plus percentage of chromium by 10 or so. So, like that if you have a steel of certain composition which have these alloying elements, then these alloying elements like manganese, nickel or chromium, they have the positive effect on the hardenability. They will try to increase the hardenability of the material, or not hardenability, basically they are going to increase the carbon equivalent value, and then elements like molybdenum or vanadium, they are going to decrease that because they form the carbides. So, they are consuming that carbon. So, that way they decrease the hardenability, and larger will be the value of these carbon equivalents. So, we find these carbon equivalent values depending upon the carbon percentage and the percentage of these alloying elements, and if the carbon equivalent value is larger, then the hardenability will be more, and there will be more chances of having the formation of martensite in the HAZ. So, that has to be properly controlled. You have to see that what is the hardenability, when you have to express that in terms of carbon equivalent, and then properly, because then weldability can be further defined for certain materials, that if it has that much of carbon equivalent, what should be the welding procedure, so that it will give you the proper structure of the welded component. Similarly, you have The alloying elements also take part in the formation of edge hardening precipitates. So, mostly in the case of non-ferrous materials, what happens that if you have alloying elements, and we know that edge hardening takes place because once you do the welding. So, after welding, because the cooling rate is quite fast, so after the welding is done, then the edge hardening precipitates may form. So, the alloying elements will be making that edge hardening precipitates, then they will be giving accordingly the property, they will be modifying the property of that area, the region where the precipitates are formed. So, this is another role of the alloying element. Alloying elements also provide the grain refinement. Many a times the alloying elements are used for the grain refinement, and in that you have normally elements like aluminum, vanadium, titanium, zirconium and nitrogen. They are acting as the grain refiners. So, what happens that in such cases they will be acting as the heterogeneous nucleating agents, and then they will be making the fine grains. So, they are acting as grain refiners in the low alloy steels. So, these alloying elements will refine the grain, and once you have refined grain, so that way you can have the presence of these alloying elements in the zone, and you can assure to be having a fine grain structure that will provide a better mechanical properties. Then reduce segregation. So, the alloying elements also they will try to reduce the segregation at times. They will be controlling the ductile to brittle transformation temperature. So, that is another challenge, because many a times when you do the welding, then the material which you otherwise could have behaved in a ductile manner, that starts behaving in a brittle manner. So there is a temperature which is there. So, above that temperature material has to behave in a ductile manner, and below that material that has to behave in a brittle manner. So, that temperature may be altered. So, that also is controlled many a times by using the alloying elements. So, this is very important for those regions where your working temperature is less. So, suppose we are working in a very high region, Ladakh region, or in the region where the temperature is very low. In those regions this is very important, and in those regions this is also becoming important, because while you do the welding, it becomes very fast. The cooling becomes very fast, because the external ambient temperature is at a very low temperature. So, that makes another challenge. So, but anyway, this ductile to brittle transformation temperature is also affected because of these alloying elements. Then alloying elements have another important role, that is they form also the carbides. So, as we know that many a times you have carbide forming elements, and they will be forming the carbides, and they provide the hardness. So, that is example of like you have vanadium or tungsten, or these are the strong carbide forming elements. So, that will be they form that, and they may affect the weldability of the material. So, another important role of these alloying element is that basically they also provide the deoxidation of the metal without loss of primary alloying elements. So, normally they will have the strong affinity towards oxygen, and they will react with oxygen, and the alloying elements loss will be less, which is basically required for the better properties of the material. So, they normally act as a very good oxidizers in many cases like aluminum or silicon or even zirconium or titanium. They also work as the deoxidizers. So, they do the deoxidation of they remove the oxygen from the melt. So, that way these alloying elements they are and then once you have the purpose is that by this means we are trying to achieve we are trying to see that the zone which is where the welding is carried out, the weld metal zone or so, that has minimum of the impurities, minimum of the phases which are undesirable for the good weldability of the material. So, that is why these alloying elements are its effect on weldability is required to be known, that what way they are affecting the hardenability or what way they make the precipitates or what way they whether they are contributing towards grain refinement. So, or whether they are contributing towards the ductile to brittle transformation temperature or so. Now, the next thing which is important to be understood in the case of weldability is that how to test the weldability. So, for testing the weldability, the purpose is to gather the information about the behavior of material during the welding, so that you can establish the correct welding conditions. Now, for when you are doing the welding with certain conditions, like if you are welding a material at certain temperature condition or with certain typical machine, you may do the welding of the same component using either the flame welding or in the arc welding. In the arc welding also you can do with stick electrodes, or you can do with TIG or MIG, or you can go for solid state welding or so. Now, the thing is that you must know that in all these specific conditions, what should be the conditions, under what condition the welding when you do it will have a satisfactory performance. So, basically the tests are carried out, and these are the weldability tests, and these weldability tests they help you to know about the behavior of this material so that you can establish correct welding conditions for a typical process. And that way they will provide you the information about what will be the appropriate welding process selection, what should be the best possible welding process for a particular material. Like you are trying to weld a material which has suppose composites. Now, in the composite or even the aluminum alloys. Now, let us say about the aluminum material, aluminum based composites, aluminum alloys, let us say first. Now, the basic challenge with aluminum alloys is that aluminum being very fast conductor of heat, you have to see that you have to have a selection. So, you cannot do with the flame welding also, because the heat extraction rate is quite high and heat input rate is very slow. So, rate of heat input is very slow. So, you cannot go with that. So, also it has a tendency to oxidize. So, this way you have to see that, but it does not mean that it is not weldable. So, you have to have the proper process, you will have to experiment different processes, and you have to counteract the different challenges which you are facing during that welding process, so that you ultimately come to a process which gives you the better and satisfactory welding process and gives you a satisfactory joint. So, similarly when you are doing the welding of certain composite materials. So, in that case you have the parent material which is softer, which is lighter, and then you have the this reinforcement matrix. Now, they have different properties altogether. It may be lighter, it may be heavier. If it is heavier, when you are doing the fusion welding, they may go and settle down at the bottom. So, you will have segregation of the alloying elements or the elements. So, that will basically not be giving you the same property of the material as that of the parent material, and then you will say that weldability is poor. But then you will have to design you will have to know that what should be the proper process by which even these materials also can be welded. So, you may go for some kind of solid state welding, where you do not give the time even to fuse them. You are joining by other solid state welding processes because of the friction which is generated, like friction stir welding or so. So, what we mean to say that in this case we try to have the appropriate welding process selection. Similarly, there may be information about the preheat. Many a times we see that if you do the welding in a normal way, it gives undesirable property. There may be hard phases, there may be cracks, but then if you do the preheating, you may do the test using different amount of preheat, and then you can see the property of the material. So, it will also talk about the preheats. Now, if you change the preheat, different value of preheat, and then you judge the quality of the weld pool, the strength of the weld pool. So, that will help you in assuring that yes, the property will be better at which degree of preheat. So, it will also help you to decide about the degree of preheat. Then you have also the information about the energy input. What should be the proper energy input by which will give you the sound weld in those cases. Then other about the joint design, what should be the proper joint design which will be giving you the weld of good quality. So, all these they are giving you these tests are carried out to give you the different types of these informations which comes out from these tests. Now, the weldability test basically, when we talk, so they are classified as either theoretical test, simulated test, or you can have the actual welding tests. So, when we talk about the theoretical test, what we do there is that we have a number of notched bend specimen, and it will be austenized at certain temperature, suppose 1150 degrees centigrade, and then we are cooling at some calculated rates to duplicate this process so that you get the expected hardness of the HAZ, and then you try to see to bend the specimen through 10 to 20 degrees. So, if you are able to bend it, you are telling that it is having a good weldability. Otherwise, you say that yes, weldability is becoming poor. So, this is about the theoretical type of test which is carried out in the case of weldability. Similarly, you have a simulated type of test. So, in that simulated test, what you do is that you are going to treat that material. So, you are giving the heating and cooling to the metal specimen over the thermal cycle, just as that is subjected in the case of welding, and then you are basically so you have a simulated type of behavior, same the way the material is subjected to that thermal treatment in the case of welding, that type of treatment you give, and then you check the properties of the material. So, that is your simulated test. So, similar to that actual welding condition, and then you have actual welding test. Basically, that test is normally you have two types of test. That is, one is you have the fabrication weldability test. So, in that we do that hot cracking test or cold cracking test, or that is hydrogen induced cracking test or root cracking, all that test is carried out. Similarly, so you have other serviceability welding tests. So, that service weldability test includes all that properties, like properties having tensile hardness, then impact test and fatigue corrosion, all that type of test can be done, and you can talk about the weldability issues. So, how once you have done the welding, whether how much it has affected the tensile properties or the hardness or impact properties or corrosion or fatigue. So, this way also you can test the weldability. If it is not affected, means the weldability is better, and if it is affected, means it has affected the weldability or weldability is poor in that aspect. So, this way way you have different aspects based on which you can even check the weldability of the material. So, similarly, you have we discussed about how you can judge about these welding processes selection. So, you can have different processes like maybe fusion welding, or you can go for the solid state welding, you can go for non-conventional welding, and you can then judge that how sometimes you can see that a material is completely not weldable because of with certain process, but that is possible to be welded with some other process. So, these all will talk about the different types of processes which will be suitable for welding certain specimen. So, this is about the weldability of material that is very important for this welding students. You should know, because weldability itself is a very vast area, and weldability issues are there with the typical elements. Like weldability issue can be discussed for a typical material, like maybe for iron based material, or for non-ferrous material, for non-ferrous of different materials, different categories. So, that way may be discussed maybe in the coming lectures. Thank you very much.